Hi, welcome to video 3. This video is titled Graphs and Transformations, and we're finally bringing graphs of functions into the story of precalculus. Okay, so everything I say in today's video should be review, and what that means is that I'm going to be going a little bit faster than if I were teaching this to you for the first time. I'm not actually expecting you to remember everything I say. Just keep in mind, I am going to be picking up the pace a little tiny bit today. And also, we're going to be doing practice problems as we talk about topics rather than saving all the practice problems for the end. Okay, so let's get started. So firstly, what is a graph? Well, it's another representation of a function, is a simple way to put it. Specifically functions that take real numbers to real numbers. So an example here is the function sine on the left. Sine gets notated sin, as you might remember. Now, I'm not expecting you to remember anything about sine, the function, and what it looks like. I'm just using it as an example function to talk about graphs. So here on the left is the graph of the sine function. And what does that mean exactly? Well, it means that I've drawn all the points x comma y such that y is equal to sine of x. That's literally what a graph means. So we can use graphs on one hand to give kind of basic estimates for values of functions. Like for example, if I wanted to know what sine of 2 was, well, I just need to find the point on the graph, this point, that has an x value of 2, and then estimate what the y value is going to be, which it kind of looks like it might be about 0.9 from this picture. Okay, so that's what a graph is, but there are plenty of things I could draw on the plane that are not graphs. For example, this circle here on the right, this blue circle, is not a graph. Why is it not a graph of a function? Well, because multiple y values or outputs correspond to points with the same x value or input. And remember, one thing that a function cannot do is it cannot send the same input to two different outputs. So we say that this particular circle that I've drawn fails the vertical line test. And you can even see that illustrated because of this green vertical line that I've drawn through it. I have 2 points here with the same x value but two different y values. That's why this is not the graph of a function. Okay. So we can use graphs to do things like compute domain and range, which we've seen before in this class. So I have two examples here. On the example on the left, I want to talk about finding the domain. So what is the domain? Well, it's the set of all x values or inputs where there is some point on the graph. And what this graph is trying to illustrate to us, or what this graph is communicating, is that there is no point on the graph corresponding to x equals 2. That's actually what that little open circle is trying to tell us. Okay, so what's the domain of this particular function represented by this graph? Well, it's all real numbers except 2. I guess I'm assuming here, by the way, that the graph is going to continue on past what we can see. One problem with graphs is that we can only see a small window of a graph at a time, so sometimes I have to make some assumptions like that. Okay, what about range? So remember, range is the set of actual outputs from a function, and when you're looking at a graph, then you can read range as the set of y values where there is some point. Okay. So we're going to use that sine function again, and we can see, because I've kind of highlighted here, that the only y values I have on this graph are the ones between y equals -1, which is the bottom here, up to y equals +1. Okay, I don't have any points up above here, above y equals 1, and I don't have any points below y equals -1. So the range of this function is all y that are greater than or equal to -1 and less than or equal to 1. Okay. So we're going to get into graph transformations next. And again, this is supposed to be review, but there's a lot to remember about graph transformations. So just before we get started, I did want to write down some tidbits. These tidbits may make more sense when we see the examples in the next couple of slides. So you might want to write these down now and then look back at them after we see the examples to see if they make a little bit more sense. But to put it simply, there are two types of graph transformations. There's horizontal transformations and there's vertical transformations. And in general, when you replace x with something in your formula, you've created a horizontal transformation, where if you do something to the entire formula, you've created a vertical transformation. Okay, so the other thing that's a difference between horizontal and vertical transformations is that horizontal transformations are backwards in a way that will make sense in the next examples, whereas vertical transformations are always done forwards. Okay, so let's get into the examples. And our two main examples are shifts and stretches and squashes. So we're talking about shifts first. So here up at the top, I have the original function, y equals f of x. That's still the sine function again, but this time I'm just going to call it f of x. Okay, now here on the bottom left, I'm going to illustrate a horizontal shift. To do a horizontal shift, you replace every x in the formula with x plus 1. So precisely what has happened is instead of y equals f of x, we have y equals f of x plus 1. Okay, that has the effect of pushing the graph 1 unit to the left. 1 unit because this is a 1 here. Oops, right here. All right, so why are horizontal transformations backwards? Because replacing x with x plus 1 has the effect of subtracting 1 from all of the x values. That's why I'm moving it to the left and not to the right, which is what you might expect. Okay, so I'm going to go over that one more time. Horizontal shift is done by replacing x with x plus something. Whatever you're adding to x, that's how much you're going to be moving to the left. If you want to move something to the right, then you're going to need to subtract something from x. Okay, so let's move on to vertical shifts. So vertical shifts are also done by adding, but instead of adding just to x, you're adding to the entire formula. So if I add 1 to the entire formula for the sine function, then I'm going to push the entire graph up 1 unit. And that's what you can see has been done here on the right. Okay. Vertical transformations are done forwards because, well, I added 1 to the formula and that moves it up 1. That's what you expect. So, okay, so just to recap, horizontal shifts are backwards and you get it by doing something just to x. Vertical shifts are forwards and you get it by doing something to the entire formula. Okay, but that's just adding and subtracting constants. There's also multiplication. We can also multiply by constants as well, and that's how you get stretches and the inverse of stretches, squashes. Okay, so here we have the original function again, just for reference. To make a horizontal squash, we replace x in our formula with x times something. So in this example, if I replace x with 2x, then I will have squashed it, the graph of f, by a factor of 2, kind of this way. You can see my hands. Okay, so again, that's kind of backwards because I've multiplied x by 2, but that doesn't stretch it, it squashes it by a factor of 2. All right, so vertical stretch is done by, again, taking the entire formula, because that's how we do vertical transformations, and multiplying that entire formula by a constant. So if I multiply the entire formula by 2, that has the effect of stretching the entire graph vertically by a factor of 2. So again, if you watch my hands, the graph has gone this way. Okay. So again, vertical transformations are forwards. There's nothing backwards about it. So if I multiply by 2, I get a stretch. So what I'm not picturing here is how would I do a horizontal stretch and not a squash? Well, you'd have to, instead of multiplying by 2, because it's backwards, you want to multiply by a half, or in other words, divide by 2. If you want to get a vertical squash, then you would want to take the entire formula and you'd want to multiply by a half or divide by 2. Those are really the same thing. Okay, so this is a great opportunity to go back a couple slides and see that it makes sense, at least this agrees, these tidbits agree with what I'm saying in words. Okay, so I know that was a little fast. And there's even something I haven't talked about, which is things like flips, which we can talk about in class. But this is meant to be review, and so what I would encourage you is to try the practice problems. And again, if you get completely stuck on them, we will do that quick practice in class, and we will get you up to speed with graph transformations. As always, thanks for watching.